Chapter 9, Problem 7. An estimated force time curve for a baseball struck by a bat is shown in figure P9.7. From this curve, determine A, the impulse delivered to the ball, B, the average force exerted on the ball, and C, the peak force exerted on the ball. So we're given only the graph in figure 9.7, so it's just a force time curve. So we can use this to find what the question is asking for. So in the question, part A, we're trying to find the impulse delivered to the ball, so we'll just call this I. So for part B, we're trying to find the average force on the ball, so that is F. Then for part C, we're trying to find the max force on the ball, so we'll just call that F max. So for part A, we're trying to find the impulse, so that it is equal to the integral of the force with respect to time. In other words, the area under the curve. So since you can look at the curve on the graph, it is a triangle, so we can just use its dimensions to find the area. So we'll have 1/2 times the base, which is 1.5 times 10 to the negative third seconds, times the height, which is 18,000 newtons. So when you multiply that together, you will get 13.5 newton seconds. So for problem B, you'll get force equals the quotient of the impulse divided by the time. So it's going to be 13.5 newton seconds over 1.5 times 10 to the negative third seconds. And that equals 9 kilonewtons. Alright guys, so for part C, you have to find the max force. So if you look at the graph, you just find where the peak of the graph is. So in this case, it's 18,000 newtons, or we can just call it 18 kilonewtons.